about a scatter plot. It shows the relationship between two variables. Okay, make sure you're doing this with us. You all right?
Yep.
All right, so what we are seeing usually here is a graph with a bunch of dots on it. Okay, it's plotting different points, so we can kind of see different patterns. A positive pattern would be something where we have an x and y axis, and when you graph all your points, you can see it's increasing. Okay, so we know with lines, if it has a positive slope, it's increasing, so a positive relationship, those points are going up. A negative relationship would be when you look at all your points and it's going down. It's also possible that we see no relationship at all. We just have a random assortment of points. I can't really tell if those points are trending up or trending down. So we can look at the graph and tell. Increasing positive, decreasing negative. If it's just random points, there is no relationship. If it's something where it looks like a line, we can create an equation for that data. That's called the line of best fit. So it's a prediction equation written when a positive or negative relationship exists. Okay, we can't do it all the time. Only if we have that positive or negative relationship. We're trying to write a line to model it, so it has to look like a line before we can do that. So the first one, we are going to look at a graph. This is kind of like an EOC type question. So a lot of times they might give you a scatter plot and say, which of these lines is the best? So this is, the data in the graph shows the resting heart rate and ages of a group of 20 people at the gym. Which line of best fit represents the data? We are going to graph each line in order to decide. So line A. Let me pass out first. That will help make good graphs here. Alright, so if I'm going to graph line A, no swinging or bending or tapping with your ruler, they're only for drawing straight lines. What's my y-intercept of that line? Y equals negative 2/3 x plus 80. How do we graph it? We go up 80. So we put a dot at 80. Okay, my slope is negative 2/3. Now it looks like my graphs are counting by 5, but since both the x and the y do that, we can just go down 2 boxes and over 3. And since I don't have a ruler, I'm going to count out a few of them. So I can draw the straight line up here, but if you have a ruler, you should be able to draw your line from those first 2 points. Okay, so this is line A. Does that look like it follows my points? No, it is well below them. All the points are above my line, so it is not a good model. If I look at line B, okay, negative 1/3 x plus 75. So my y-intercept is 75, so we start at the 75. Then we go down 1 box over 3. Okay, again, you only need 2 points. I'm doing more because I can't draw a straight line up here very well. Okay, so once you get those, draw your line. Does graph B look like a good model? Pretty good. Let's go ahead and look at the others just to see if one is better, because we're trying to pick the best out of all of them. But we know B is, the blue one is definitely better because it goes about through the middle of the points. We have some above, some below. It's about the same steepness as those points. So if I want C, my y-intercept is 80 again. My slope is negative 1/3, so down 1 over 3. Does that one look like a good choice? No, all of the points are below that line. You want one that goes through the middle with about half of the points above and half the points below. So this is not a good choice. If I do line D, y equals 50. That's just a horizontal line at 50. There's no x in it, so it's just a straight flat line. Remember our hoy and bucks? So if I look at that, that is definitely not even close. So my best choice here, line B. All right, so given a multiple choice question, you just really have to graph those lines and kind of figure out which one's the best. All right. So in that one, we graphed every single one. Are we okay with that? Let's look at the next question. So I'm again asking for which one is the best. Okay? If I look at this, can you tell me, is this data positive or negative?
Negative.
So negative, because it's decreasing. If it is a negative relation, that means the slope has to be negative. So we could automatically mark off A and C. Those have positive slopes, so they would be increasing. So we can get rid of some of them. We don't have as many to work with. So then if I want to graph B, my y-intercept is -2. My slope -3, so down 3 over 5. Or you could go up 3 and backwards 5. Is that one a good line for my data? Not really. I mean, it kind of goes, you have some points above and below, but it's a lot flatter than the points are. If I look at D, okay, that one starts at -2. My slope is -5/3. So we would go down, although my graph doesn't even go down that far, but we can kind of estimate it, over 3. Or you could go up 5 and backwards 3. Okay, is that one a better model?
Yes.
Yes, because I see it's got about the same steepness, about half the points on each side. So D is the better graph here. Alright, I want you guys to do number 2. You are trying to decide what the best choice would be here. Is there any way I can narrow down my choices to begin with?
You can get rid of the negative.
If I look at this, it is increasing. So that means I have to have a positive slope. So anything with a negative slope, I automatically know is out. So now I have a 50-50 shot. So let's just kind of graph them and see. Y equals 2x plus 3. So that would start at 3. Slope is 2, so that's like 2 over 1. So up 2 over 1, or you could go down 2 and backwards 1. So if we graph that, does that one look like a pretty good model? Yeah, it's going right through the middle of our points. We have some above, some below, so that is a great model. If you looked at B, it starts at 3, but its slope is 1/2. So up 1 over 2, or down 1 backwards 2. And so we see if we graph that one, it's not close because it's too flat. All right, we are going to keep doing these until everybody's getting them. So, if you don't want to do all the ones on the paper, then everybody should try this one. Number 3. Give it a shot. See what your best one is. Is this at all? Is this increasing or decreasing? Increasing, it's rising, so I know my slope will have to be positive. So if I know that, I can automatically mark off B and D. Okay. If I try to graph these, y equals 4x. That's like 4x plus 0. My y-intercept is 0. Slope 4 over 1. If I go up 4 and over 1, or down 4 backwards 1, is that anywhere close to my points? No, it's way too steep. If I do the other one, 1/4 x is like plus 0. So you start at 0, up 1, over 4, or down 1, backwards 4. That one is a pretty good model. So the correct answer here is C. The 4 is just too steep, and we know it's positive because it's increasing. If I look at number 4, positive or negative? It's a negative slope because it's falling. So I can automatically mark off the ones with a positive slope, which is just A on this one. Okay. When I look at this, if I started graphing these lines, C, that has a y-intercept of -2. Slope is -1, so down 1, over 1. Is that close to my line? No, I actually have a typo on here because C and D are the exact same answer, aren't they? But that one's not right because my y-intercept isn't negative here. If I look at B, my y-intercept is +2. If I start at +2, slope of -1, down 1 over 1, or up 1 backwards 1. That one is a much better choice. So, save yourself some time by marking off any obvious wrong choices. Look at positive or negative slope, mark off what you can. From there, then you can kind of graph what's left and see which one it is. Let's see if we can all get number 5. Positive or negative slope? Negative, it's falling. So I can automatically cross off 2 of them. Okay, if I graph them, y-intercept of -1, slope of -3/4, so down 3 over 4, or up 3, backwards 4. Is that a good model?
Yes.
Yeah, that one's really good. If you did the other one, you started at -1, your slope was -4/3, so down 4 and over 3, up 4 and backwards 3. And so we see it's not horrible, but it's a little bit steeper than our points. So C was the better option. All right, what I'm going to do, we're going to take a couple minutes. I'm going to show you one thing on the graphing calculator, and we're going to do some more of these tomorrow, but I want to go ahead and teach you something. So everybody needs a graphing calculator. This will make your life much easier. Please.
I didn't mean to, that's hard.
Okay. If you have a set of points like this, we can write the line of best fit for it. So we've just been looking at a graph and trying to pick the best one from a choice, but we can get the true equation. Now, you can like draw the graph and try to write the equation yourself, but we have a resource that makes it much easier for us. These are like our x's and our y's here. We are going to enter this data into our calculator and have it write the best equation for us. So on your calculator, you are going to go to stat. Right? If you don't see the button, look up here. It's the row with the green button, third one over. So you hit stat. Should look like this. And we are going to go to number 1, edit. Now, you'll get 2 tables right now. They may or may not have information entered in them. Here's what I need you to do though. Do not use the delete button if there's information in it. Because it'll actually like take out the entire column in this table and then nothing else works as it's supposed to. So if there is information entered, what I want you to do, use this up arrow until you have the list highlighted, so it's probably an L1 or L2. So you highlight that, push clear, not delete, just clear, enter. And it will wipe out all those points, but not delete the entire list. So you use your arrow buttons until you highlight the name of it, clear, enter. And so we should all be looking at blank lists right now.
I do cool.
I said, do not push delete.
You didn't say that before I pushed delete though, because I opened it and immediately pushed delete.
Okay, did anyone else delete out the entire list? So now, what we're going to do is we're going to type this data in. We're going to do this row in the first list, and we'll do these points in the second list. So, I'm just going to type 0, enter, and it goes to the next one. So my next number was 10, enter. 20, enter. 30, enter. It is important to put them in order. Once you get all of them entered in one list, you can just use your arrow to go to the next list and list the next points in order.
Then you press graph.
No.
Oh.
Check when you get to the end. They should end at the same spot. These are like order pairs. 0, 79, 10, 81, 20, 79. So the last one, 81. If one column is longer than the other, you made a mistake. So now, what we are going to do, this tells us all of our steps. you are going to push the stat button again. So we put stat. We don't want to edit anymore. We already did that. We're going to use the right arrow and go into calculate. This is all the different things that your calculator can find for you. But we are trying to write the equation of a line. So we are going to do number 4, the linear regression. So stat, over to calculate, the 4th one. Enter. All right. As long as you didn't delete out your list, this screen, we shouldn't have to change anything. It should all be set up correctly. So I'm just going to hit enter until it takes me out of this screen. So I go through the whole list, and then it shows me that.
I didn't get the R's.
If you don't have the R's, that's okay. That's another setting on the calculator, but we're not using that. So it may just have the first 3 lines. It might have all 5. It doesn't really matter. Our equation is y equals mx plus b. When we look at our calculator, it tells us y equals ax, and then underneath it says a equals. So my a is
1.0716666667.
I'm going to round to 2 decimal places. So negative 1.07x plus b, and my b is 92.866, so 92.8, that 6 would round up to a 7. Alright, did everyone see how I got that equation from my calculator? So it gives you the a number as your slope, the b number is your y-intercept. Round it appropriately when you put it down. So now we have the equation. We didn't have to do any of the calculations ourselves. Part B, estimate the average temperature for a city with a latitude of 48. In this table, it's doing the first one as your x and the second one as your y when it writes our equation. So when I look at my latitude of 48 degrees, latitude was the first row of the table, right? So that was my x. So what this means is my x is 48. So now I'm plugging that into my equation. So I am replacing the x. I know x is now equal to 48. So I plug that in. That's my y. My label on that is degrees Fahrenheit. So we wrote our equation and then we solved it, just like with those word problems. We were writing an equation, then I would give you a value that we had to plug in. All right.
Special.
I'm confused.
Okay.
I have 144.
Oh,
What?
you didn't have the negative on there. There you go. All right. I am going to stop here today. Tomorrow we are going to do some more practice with this. Do not put your binders up yet. I'm going to give you